prevent contamination and ensure the safety and efficacy of products, particularly in industries such as pharmaceuticals, biotechnology, and food processing. Here are some methods and principles commonly employed to maintain aseptic conditions. 1. Sterilization. The first step in maintaining aseptic conditions is to sterilize the equipment, surfaces, and materials used in the sterile area. Sterilization methods include autoclaving, steam under pressure, dry heat, filtration, and chemical sterilization. 2. Clean room design. Sterile areas are typically designed as clean rooms, which have controlled environments with low particulate levels. Clean room design includes features such as high-efficiency particulate air (HEPA) filters, positive pressure to prevent air infiltration, smooth and easy-to-clean surfaces, and proper ventilation systems to maintain air quality. 3. Personnel training. Proper training of personnel is essential to ensure they understand and follow aseptic practices. Training should cover proper hand hygiene, gowning and degowning procedures, aseptic technique, and clean room behavior, including minimizing movements and avoiding unnecessary talking or coughing. 4. Personal protective equipment (PPE). Sterile areas require personnel to wear appropriate PPE to minimize the introduction of contaminants. This typically includes sterile gowns, gloves, head covers, face masks, and shoe covers. The PPE should be donned and doffed following specific protocols to prevent contamination. 5. Cleaning and disinfection. Regular cleaning and disinfection of surfaces, equipment, and tools in sterile areas are crucial to maintain aseptic conditions. Only approved disinfectants and cleaning agents should be used, and proper cleaning procedures should be followed, paying attention to critical surfaces and areas with a higher risk of contamination. 6. Environmental monitoring. Regular environmental monitoring helps assess the cleanliness and sterility of the area. This includes air sampling to measure particulate levels and microbial monitoring to detect any potential contamination sources. Monitoring results are used to ensure that the sterile area is operating within acceptable limits. 7. Traffic control. Controlling the movement of personnel and materials within the sterile area is vital to minimize the introduction of contaminants. This can include having designated entry and exit points, gowning and degowning areas, and restricted access to authorized personnel only. 8. Material transfer and storage. All materials and components brought into the sterile area should be appropriately sterilized, packaged, and stored. Sterile transfer methods, such as using laminar airflow workbenches or pass-through hatches, should be employed to prevent contamination during material transfer. 9. Continuous process improvement. Implementing a continuous process improvement approach ensures that aseptic practices are regularly reviewed, monitored, and updated as needed. Regular training, audits, and feedback mechanisms can help identify areas for improvement and ensure compliance with aseptic principles. It's important to note that the specific methods and principles for maintaining aseptic conditions may vary depending on the industry and regulatory requirements. Following industry-specific guidelines, best practices, and regulatory standards is